All right, so we stopped around this slide. With many of you, uh, with some of you, I've also finished this slides, but let's jump in and let's try to close the topic of chapter 2, and also let's go and start with the topic of chapter 3 and let's finish it. So data presentation, um, data is represented by zeros and ones, as you see they are. So here, if you represent the data in binary code, that means 0, 0, 1, and 0, and that would mean in simple decimal code 2. Why? With the last number you start, so from backwards to the front, 2 powered by 0 would be basically 1, and then times 0 would be 0, right? Then 2 powered by 1 is 2, times 1 means 2. So ones and zeros, as you see here. Good, the next slide also reminds us how it works and what the reason is. It is very simple. The reason is that the data to 1, 2, and 0 is easier to be counted, and additionally the electricity what you use for switching on and off, it's much less because that's only 2 stages. So two states are available, so 1 and 0, and this because only 2 states are available, you don't need much more energy to switch to 3 and 4 and 5 and so on up to, let's say, from 0 to 9, right? And then so the computer receives the information electronically, either 0 or 1, and then the microprocessor is working on it, and it will then, after the process, provide an output either on the monitor or on the printer. Once again, 1 byte is equal to 8 bit. That's the binary digit, and on and off state or 상태 is possible for 1 single bit. Okay, here an example and the quiz additionally, which I already showed you, and then here another example also for binary. There are types of people in the world, those who understand binary and those who don't. Now, obviously this is not 10, but it is 1, so understanding binary, so on, and then off for 0, so those who do not understand binary. Okay, the remaining slides are explaining how you can change the decimal to a binary system and then it also gives you an example. So here the binary to decimal, again, that is binary code, so we start from the beginning, which is 1, which means then it's 1 times 2 powered by 0, so it's 1, and then plus 2 powered by 1, so it's 0, and then plus 2 powered by 2, it's again 0, and 2 powered by 3, it's 8. So we got 9 together. Good. So you know that there is computer hardware and software, and you know that 명령어A, 명령들의 집합. So the set of instructions means a program, and you also know what is a 해석기관. You also know what Ada Lovelace, Charles Babbage, and Jacquard did, what the punching means, the punch cards mean. Then what does the CPU mean, main memory, then the storage itself, and input and output as well. So the main memory is used until the computer is on. The storage, the secondary storage unit, is used for storing the data for a long time. Main memory is used only if the computer is on, means that if you switch it off, then all the data in the main memory will be lost. Then computer counts in zeros and ones, so binary codes and bit and the byte itself, it's to powered by 3, so that's it. Here are a few questions, and also focus please on a few examples what we have here. We have here a few examples, so please try to read the book a little bit, would be helpful. Right, that's it. And we can count from here directly to chapter 3. So let's go and take a look at chapter 3.